Welcome to week 4. We're going over chapter 5, fruitful functions. I hope you're ready to dive in because this chapter has a great bit of information and is very important. Now let's start off with the section 5.1. It's talking about return values. In the past we talked about many different functions, so we're still over functions. We talked about math functions, which are predetermined or predefined functions. Um, and we talked about generating new functions, which we can assign something. And what we had was one-liners, or what we have in a void function. Everything happens inside the function, our void function, and it doesn't return anything. However, this chapter we're going to learn how to return something into our main, and we can do something inside our main and we can go from there. Now I'll let you know ahead of time that since this is a lengthy chapter, or this will be a lengthy chapter, I'm only going over a few parts. It'll be section 5.1. I will go over the coding, and I basically will be kind of reading from the book of section 5.2. I will actually stop there and let you do 5.3 through 5. And 5.4 on your own, and then go over 5.5 in a new video. So let's go ahead and continue and see what we have. So first off, we have here, when we talked about in this chapter, we're going to write function and return things, um, in which the book refers to as fruitful functions. This is just something, a function that's returning a value. Now, in this case, I've written just about the same thing that we have in the book, which is this first part right here, lines 8 through 13. We show here may be different in yours. It's according to what you do here. It doesn't have to be the same. It just needs to, yours just needs to look something similar. Now, the difference what we have from the past is I have a data type right here. Now, if you read in the book, you will learn that this data type shows that this is what we're going to, this is the value or data type that we're going to return to our main. So it can be different from the function's parameter. However, in most cases, you will see, if just like you see here, if you're gonna, in your parameters, if you're gonna actually get a double, in this case, you're most likely going to return a double. Okay, so what we have here is information being input into the function, which is radius, and and please look, I do not have it's not running right now. This is not a full running program. I have to insert code, so we'll do that later on. So what we're doing, we're inserting a double with the variable name radius. Okay, now inside our function, we're going to have the double pi. That means we're declared pi, and we're going to do a math function. So um, with our math function, we have to have CMath because we're using math functions, and we're going to have that as negative 1.0. Now the next line, we're declaring the area, which is pi. So somewhere we're going to have to say what is pi, which we did right here. So we say the outcome of this is equal to what function, or what we get inside our radius here. Now, if you're wondering why, or you're saying, okay, since we have the CMath function, CMath header, excuse me, why aren't we using power? Sometimes we can use the power function or the power function, and sometimes it's just easier to write it out the long way. I'm doing it the long way right now. However, in our upcoming codes, will actually use the some of the math functions. So what we have here is return area. Now if you notice in our void from the last sections or last videos, you see it will just say return. So when we return, it will stop the program or stop the function right there and then go on back into the main to the next line. Now here we're actually returning a variable which will have some type of value. Okay, so let's see. The first thing that we have to do is actually we have to call this function right here and then pass some values through there. So let's say area, and let's pass a value of 1.0. Alright, now when we're doing this, we pass the value of 1.0 and then we're going to return area. So to see that it runs correctly or see that we get an output, I wanted to put cout area so that we can see something. So let's go ahead and save this, and we're going to save it as section 5-1.cpp. Okay, compiling it, and we're running it, and we get the answer of 1. So in this case, sometimes you can set your values, or even you can set your coding to do something different so that you can get an outcome of what you know that it's going to be. So let's change this value of 5.5 and let's save, run it. Still get 1. However, I'm not sure exactly what our outcome should be. So what I'm going to do is actually just delete this. Yes, let's delete this whole thing. Let's delete this as well. And we're going to start off a new coding of our own. And we want to put we actually want to call this, I'm going to call it something else, number. Okay, and inside here what I want to do is set a int oh no, let's try double area, or let's call this something else, square. Double square equals number plus number plus number plus number. And we're going to return square. Okay, now let's see, Did I? Yes. Now what we're going to do is call this square, call this function, and have the number 1. You know what? Let's not do doubles. Let's change it up. Do apologize. Int. Because we want to make it as simple as possible. So we're going to make it an integer, and then we're going to see out square. Now let's hope this works. Let's save it. Let's run it. Now I think what it is coming to, we're going to square. We're going to return. Oh, that's right, because we're turning a value, we're not actually getting that value. See, we're having a little difficulty, so we want to see what is actually going on. Let's see out square, and let's see if we can get some information right here. And we have that. Okay, so we're getting information here, but we're not displaying it correctly here. Let's see, can we actually get it displayed correctly here, because what's the use of returning something when we're not able to do so? I'm actually going to pause the video and check my coding, and I'll be back. Okay, we're back. I checked my sources, my book and internet, and I've noticed the mistake that I did. Instead of me putting it all in one, I've actually tried to separate, and that was a no-no. So I think I've actually stepped over into further chapters. I'm not sure. However, you'll get a heads up or a good lead of what you're supposed to do in future chapters or sections. What we have here is that we're going to, in our main function, that we have what we have here. Let's see what we have here. Excuse me. We have the cout. We're gonna call the function, have it go through the number 1, add, do something, which we're gonna add number 1 4 times, and then we can take this out because we found out our problem. And then what we're gonna do is return square, return the value through square, and then this is what we're going to have an output. So let's see. Save it, run it, and we have 4. And this is the number that we have output. Now we can actually put that number here inside, or we can put it here. The reason why that we return values, just in case we want to do something, and you can use this when we go to the next video to enhance your Boolean values, or you can use it for your logical operators. And that's what we're going to do in the next video. and then show you what's going on from there, or you can create a program to use from there. Alright, let's go ahead and move on because this is going to be fairly lengthy. Alright, in the next section, which is section 2.5, is called programming or program development. Now, program development is actually doing something of what I have already been doing in the past. It's taking a bit long piece of program, um, doing it short, breaking it down into shorter pieces, running those shorter pieces, and building up as you go. For example, we take something, or we can just go ahead and jump right into the actual with the book. Is the It says an example: imagine you want to find the distance between 2 points given by the coordinates x1 y1 and x2 y2. By the visual definition of, we're finding the midpoint. Now, if you see here, this is our math problem. So if you're already in the math, you should know what I was talking about before I pulled this up. The distance equals the square root of x1 minus, x2 minus x1 squared plus y2 minus 1 y1 squared. So what we're going to do is actually take this and step by step, and what you call incremental development is take it step by step, see and code it, see an output, and then make it as we go, increment it, see what we need, and keep going from there just to see our codes and make sure that it works properly. Okay, the first thing it says, the first step is to consider what is the distance function. So we figure out what the distance function is, something you will have to look up, and how it look in C++. Now, in other words, that we're going to be using a function, and we're going to be using parameters, and we're going to have to know the output of those parameters. So in this case, the 2 points of the parameter and its natural nature to represent them using double functions. So when we see this, we're going to, it's kind of used as fractions, or sometimes we use it as doubles. You're not in always going to have a integer value for your different points. So we write it as such: double distance, and because that the distance is going to be in a double or floating point, so we use double, and we said our different values is going to be in a double, so we say double x1, double y1, double x2, double y2. Now in this case, we see that we have x1, y1, x2, y2. We have to make sure that you know the order that you're going to have it in, because that determines what is what. So in this case, for right now, we're going to return 0.0. Oops, if I spelled return right, turn 0.0 to see an output of what we have. Now I've already goofed up right here. I put this in the main, and this actually all supposed to be outside of the main. So let's take that out and let's work on that here. So the return statement is a placekeeper so that the function will compile and return something, even though it's not the right answer for right now. At this stage, the function doesn't do anything useful, but is worthwhile to try to compile it so we can identify any syntax errors before we make it more complex. In order to test the new function, we have to call it with sample values. And we'll actually call this, you have to call it inside our main function. So here is actually where we do something. So now, as you see in our previous statement, we can actually call it our distance, or call our information right here. Sorry, that was my phone. I have a 10:45 appointment somewhere. However, I have to finish this first. Alright, so this is what happens, and this is what we could have done in the previous section here. We created, or we declared, a variable double, and we called it just dis, shortened for distance, equals distance, and we're going to have values put in here: 2.0, 4.0, 6.0. Okay, now we have these values in here, so the values are going to go in its respective place, as in this is going to be x1, y1, x2, y2. Okay, so the next thing we have to do is actually get an output. We're going to output distance, then we're going to throw an inline in there, and that's it. So let's run this one, save it, compile it, run it. This is section 5-2.cpp, and let's go ahead and save this. Oh, we have an error. Oh, because we didn't put a semicolon back here. Let's go ahead and save that. And again, run it, and our output is going to be 0. Okay, so we do have an output right here. It's going to be 0. We haven't did anything to the values that we put in here. We did return something, which is 0. I'm not sure why it's just 0 and not 0.0 at this moment. We'll have to look into that a little later on. Now, the reason why we chose 1, 2, 4, and 6 is because those values, that the horizontal distance is 3 and the vertical distance is 4. So like I said earlier, and you need to know your outputs of what you're using, so that way in the results we should equals 5, because a hypotenuse of a 3, 4, 5 triangle is 5. Alright, when you are testing a function, it is useful to know the right answer, as I just said. Once we have checked the syntax of the function definition, we can start adding lines of code one at a time. After each increment change, we recompile and run the program. That way, at any point, we know exactly where the error must be in the last line we just added. The next step is the computation. Is in this computation is define the x2 minus x1 and y2 minus y1. So let's write that out. So everything that we have right here is finished. We're just going to be working in our added function. So we put, since we have already numbers, we're going to just take x2 minus y2, we're going to say we're looking for the difference, so let's call it dx equals x2 minus x1. Alright, so, and we do the same thing for y. Double dy equals y2 minus y1. Now, these are dx and dy are used just for temporary values. They're something that we can hold, so we will be able to get information later or use those values. So let's go ahead and make sure that this is correct. Excuse me. Dx 9, and I'm going to do a little shortcut, copy and paste. Make sure everything, we want the dy here, and we want the dy here. So let's go ahead and compile it, run it, and see what we get an output. So 3, 4, and then we have 0 at the end right there because nothing's returning just yet. Okay, matter of fact, let's go ahead and leave this as a comment so we won't have that confusing us. So let's go ahead and file it. We'll see it without the zeros. Dx is 3, which is, we have x2, and let's get this over. X2 is 4, x1 is 1, so 4 minus 1, 4.0, or 4 minus 1 is 3, and we have y2 minus y1, y2 is 6, y1 is 2, so that equals 4. So that is correct. So let's move on. Okay, now we're looking for the square root of the dx times dx. Well, we're looking for this, we do the square, excuse me, we do the square of both dx plus, is dx squared plus dy squared. So in this case, the book uses only uses both of them together. I'm going to use the POW function, and we got a new variable in here called d squared equals POW, and it takes 2 arguments, which dx is the first one and 2 is the second one, so it's squared, plus POW, and again it takes another 2 arguments, dy comma 2. And let's drop that right here. Since we know these work, we're going to take this off. Let's leave it right here. And what we're going to do is, actually, let's say d squared is, and make sure the d squared works, d squared and let's compile this, rerun it. Alright, d squared is 25, so we should get 25.0, but let's see, we'll look at that in a few. Okay, so our next thing is to take the square root of d squared. So I'm going to do double results equals sqrt, and we put that number in there. It needs to be, should be a double number, squared. Now I'm not sure this is going to be 2.02. That's just my thinking right here. Now we, instead of 0, we return result. Now right here we can go ahead and take this out. Let's bring this up. Now let's see. What do we have? We should get an output of 5. Do we? Yes. Now, what we've done here, or what happened, is that we had a, well, we returned a value, and it's this value right here. This value does not have to be the same thing as our function name. It just needs to be placed in something, and it will pass through here. Now, with that being said, from what we have here, it our value will be automatically placed here, even though we're passing the values. It's all done at one time. We pass the values, then this distance will end up with the value. So our what we pass through here, these will be passing through into these, double x1, double y1, and so forth. And we will go through the operations or whatever we need to do, have this, it will come back and be stored into the dist, and then we output the dist, and then we see our values. It's somewhat difficult to learn or difficult to understand. However, if you do it in a more simpler form, you can even just pass values as I did here, just small values. You can just pass one value, uh, add, do the adding of the value, and you will understand things of that nature. And then you can work your way up to a more complex value or a complex problem. You can easily find a math problem or something like that. However, if you notice, if you're able to extract this, or if you want to extract this and put this on your computer, um, later on down the line, where you'll notice where you can put in inputs, or you can have user inputs right here, instead of numbers right here, you will have um, variables, and you can say what is x1, and you can have that variable right here stored in there. What is x2, x3, and boom, you'll get your results as it is. How we did it right there, you'll easily get your results. So that way, this is a quote unquote way to not have to show your work, or if you do not have to show your work, you can look at it through here, through this program, and you will have your quick way of actually finding the distance between 2 points. Alright, this is the end of this video. It may seem a little choppy because I start and stopped at certain places, and I'm going to squeeze all these together. and I will see you back in the next section or next video going over bullying values. Thank you for watching.